Okay, well, that doesn't add up to 10x either, and we've run out of whole number options. So what you could say is this isn't factorable with integer values. So we can't find the x-intercepts using that factoring strategy. Okay, so let's pause on that for a little bit. Maybe instead we could at least figure out the vertex algebraically. So to find the vertex really easily would be by changing the standard form equation to vertex form by doing something we talked about last week called completing the square. So instead of a rectangle, we want a perfect square with the side lengths exactly the same. I need 10. So I only have 2 more x's to use. So if I put them here, I'm out of x's, and now this is a 3 and this is only a 2. So that's not a perfect square. If I put these 2 over here, it'd be the same, but like 3 would be here and 2 would be here. So it looks like with these pieces, I can't make a square exactly like we were doing before. So again, the strategy we're using to change to vertex form isn't working out as nicely. Remember, I mentioned before we were using only examples where it was just x squared. There wasn't a number. Well, the number in front was 1. So my one last little effort here to change it to vertex form would be like, okay, we know how to do it if it just said x squared. So let's try to get rid of that 4. So if I want to undo this multiplying by 4, I could divide everything by 4. So x squared plus 10/4 x plus 3/4. And then maybe try drawing that square again. Okay, so now I have one x squared tile. Now I want to split this 10/4 in half. Oh Lord, so now we got 10/4, the fraction, divided by 2. Oh my gosh, this is already getting so much more complicated. You are going to learn how to do this method with all the fractions and loveliness next year. But for now, we're going to pause on this and get to a different method that's actually going to help us find the vertex and x-intercepts for any standard form every single time. All right, so I'm still going to keep this goal in mind, finding x-intercepts and vertex algebraically, but I want to derive a method that will work all the time for any quadratic, no matter what. So to do that, I have to not use a specific example, but use something that has only variables, no numbers. So I'm going to just start with our standard form quadratic, ax squared plus bx plus c equals y. Okay, so before, with that specific example, one technique I tried to do to get to vertex form was to divide out that a value so that I could just use our old strategy with just 1x squared. So I'm going to start by doing we're not totally in vertex form yet because we have this other stuff happening with the y. So let's get y by itself. So this is our vertex form. Looks kind of crazy and messy. Remember from that specific example, we knew just starting out by drawing the square, we're going to have some fractions to deal with. That fraction kind of mess in more algebraic terms. I want to do one last thing to get this truly in vertex form. I'm going to combine this part to get the like k plus b over 2a squared plus. In order to subtract these, we would need a common denominator. Just for the sake of time, I'm not going to show every single step here, but that would be 4ac minus b squared over 4a, right? We'd multiply this one by 4a over 4a equals y. Okay, so to generalize this so far, remember vertex form. This is h, this is k, and hk is the vertex. So we now know to find the x value of a vertex of any quadratic written in standard form, you could do negative b over 2a. The reason why it's negative here, remember vertex form is x minus h squared. So we have a plus here. So that means it was a minus negative b over 2a. So that's this part. So you may see this next year. Some teachers don't emphasize this as a strategy. Technically, then this is how you could find k, but most of us don't memorize this idea. Instead, we use what we know about the x and y relationship. So if you know the x value by using this little formula, you could just plug in that x into the equation to get k. So I'm just going to write f of negative b over 2a, and you would get the same value. No one ever expects you to memorize this idea. All right. So we're at vertex form. So we've completed half of our goal list. The other part was to find the x-intercepts. Anytime you're trying to find x-intercepts, you have to start by replacing y with 0. So you can solve for the x that makes that 0. All right, here we go. Okay, replace this y with a 0. And now I'm going to start trying to isolate this x. I'm going to start by adding this. I'm sorry, not adding. It's already adding. I'm going to subtract this piece to the other side. this, I'm going to do one more thing combining these two denominators. This is what you're going to see more often. Negative b plus or minus the square root of b squared minus 4ac all over 2a. This is called the quadratic formula. Remember, this whole thing was to find those x-intercepts. We replaced y with 0 and solve for x. So this quadratic formula will tell you the x-intercepts of any quadratic written in standard form every time. Any standard form quadratic. You can use this quadratic formula to find x-intercepts of any standard form quadratic. All right, so now I want you to go back to that original problem. And now using this quadratic formula and vertex idea, remember vertex, you can find the x or the h. This would be negative b over 2a. To find the k, I want you to plug in that x value you got into the equation f of x, and then to find the x-intercepts, you're going to use the quadratic formula.